Hey guys, and welcome to a new video in this C++ tutorial. In this video, we're going to talk about structs and what we can use structs for in C++. And in the next video, we're going more in depth with object-oriented programming, and we're going to talk about like how we can create classes and divide our programs into classes, and then work around with the object-oriented programming, which is like a really important topic in programming in general, and also in the C++. So first of all, we're going to talk about like what structs are, and they're used to like create an instance of a class. So let's say like for example we have the example over here, we have the student here, and then we can create a structure or like a struct of that student, and then it can have some like different variables and like data types inside of that structure that we create. So structs are used for like lightweight objects as like for example like rectangles, colors, or points. And also if we just like have a student which has a name, an ID, and an age, or like if we have a rectangle, it could have like a size, like a length and a width, and then we can have like also like a point which has like an x, y, and z coordinate. So they're used for like lightweight objects and in just like a collection of different data types, and then it makes you able to like create your own data structure where you can have like a structure where you just like have your own data that like describes the structure that you're creating. So you can create a structure, and then you can like access the variables or like the data of that structure that you create. So if we compare like structs to classes, which we're going to talk about in the next video, and we're going to like go more in depth with object-oriented programming and classes because it's such a really like important topic in programming. So a class can like it can also like contain methods which structs can't. So we can like have methods that can be called on our structures. Like structures are only like for containing data for that structure that we're creating with different kind of data types. So we can have like different kind of data types, but we can't have methods or like functions inside of our structs. So, and also like the member variables and the methods are hidden from the outside world when we're talking about classes and when we're working with objects. So like we can't access like the variables of the class or using the class methods outside of that object that we created from the class. Whereas structs, like they can be seen from everywhere in our program, so we can just like have the structure that we create, and then we can use its member variables everywhere in our code. So classes also has these constructors and destructors, which is like when you have a constructor. So when we initialize an object, we use a constructor to like give them some like initialized some data or like member variables. If we want to do that in some situations, where in structs we don't have like the constructor and destructor. And when we're talking about classes, we also have this inheritance where we can inherit from other classes. So let's say we have like a person class, and then we can have like a female and male and like genders, or like we could have like a family, then we have like parents, children, etc. So like we can inherit like the member variables and methods from like higher level classes which we're inheriting from. So we're going to talk about a lot more about this in the next video here, but it's just like to give you a short introduction of like what we can use like a class, and also like a lightweight class like a structure too. Structs, they're public as default, so we can like access them everywhere in a program, where classes are private at default. Like we can also set the member variables and methods in classes to public, so we can access them everywhere in our code. But most often we want to like keep them private, and then use our methods and member variables on the private object, and then we can like have some access functions that can like interact or like get the variables and also like modify the variables inside of our object or like class. So we're going to talk a lot more about classes and object-oriented programming in the next videos, because it's just like it's such an important aspect of programming, also just like modern programming, because we can like it just makes it easier to write code, and also like to divide code into smaller like classes, and it's easy to debug and also write. But also like for portability, so like if you're creating a class, like you can just have that you can just like take that piece of code and move it to other applications or program that you made, and where you want to use that class that you've already created. So we have this like circle over here with object-oriented programming, and we're going to have videos like describing all of these aspects of object-oriented programming. So we have like a class, and that class can like have attributes and methods, and we can create objects of that class. We can also have like some encapsulation, inheritance, abstraction, and polymorphism. So we're going to talk about more about that in later videos, but now I'm going to show you some examples of like how we can use structs in C++. So we're not just Sublime Text here, and I'm going to show you some different kind of examples of like how we can use structs in C++. So first of all, we're going to just include the libraries that we're going to use in the code here. So the first struct here we're creating is this product structure here. So we just created with writing this keyword here, struct, and then the name of the struct that we want to create. And then we need these curly brackets here to create our structs inside. And then we have our variables, or like our data types inside of a struct here. So this product struct here has a variable with the weight and a price and an amount. So amount of the product, the price of the product, and the weight of the product. So we can create an instance of a struct with this with like declaring a variable name here after the struct that's ended, or we can also like create it as a class down here where we have what we call this struct keyword, and then the name of the struct, and then the name of the instance we want to create of that struct. So in this case, we're creating an apple of the instant and as an instant of the product struct here. So we can also use like this notation up here, or we can use them like if we're like operating with normal classes in C++. So our first example here is that we first of all we create a struct here called an apple. So we have an apple here, which is a product struct. So, and then we can access the variables inside of the struct with this dot operator here. So we can access the weight or weight variable inside of the struct here with calling like apple.weight, and then we set that weight of the apple here to 0.1, and we set the price to 0.2, and the amount to 3, and then we can print it out down here where we just like again access the members or like the variables inside of the struct here with this dot keyword here, and we can access like as we talked about in the slide, we can access these variables everywhere in our code because they're public as default with structs, where if we're operating with classes, we can't use this dot operator here if we have private members of that class. So if we print this out here and hit Ctrl B to run the program, we can see that first of all it'll just print out the price. So we have now set the price to 0.2 and the amount to 3, and then we can calculate the total price here. So we can also just like access the members here, do some operations on calculations on them, and then like store it in another variable or print it out. So in this case here, the total price will be 0.3 when we're buying like 3 apples to $0.2. So another example here, if I'll just comment this out here, we can also create like another structure, a banana here, and then we can also like use pointers, as we talked about in the 2 previous videos. We talked about pointers and smart pointers. And we also like can create the instance of our structure, like the melon and peas here, and then we could like use the melon down here, for example, like melon here dot price, and then we can set the price to something here. So we can also like create a structure or like an instance of the structure like that. So here we're going to like create a pointer here to that structure. So first of all, we have our structure here, banana, and then we create a pointer that is pointing to that structure, banana here. And then we just set the pointer here equal to the address of the banana here. So we have this pointer pointing to the address where this struct here is stored. And then we can access, as we talked about in some of the previous videos, that we can access like classes or structures with this arrow operator here. So we access the member variables or like the variables of the structure with this arrow operator. So if we want to like access the weight and price and amount here, we use this arrow operator on the pointer, and then we just set the values that we want to set the variables to. So as we talked about in the videos about pointers, like the original pointers or raw pointers, they're not a good approach when we're talking about like modern C++ programming, because we have these unique pointers that actually like takes care of memory allocation by itself, like automatically, and then it will like destroy the pointers when they go out of scope, and we don't have to like care about our program crashing and causing memory leaks when we're using pointers in a program. So as we talked about in the last video, we can create this unique pointer here, which is just a unique pointer. So we can only have like one pointer pointing to one object, and it is not possible, like it will throw a compiler if we have like another pointer trying to point to that exactly same object. So in this case here, we have this pointer here, which points to a structure of like a product here. And then we have like the name here of the pointer, which is just P1, and then we just create a new instance of this product here. And then we can access again, when we have like these pointers, we can access like on this pointer, we can access it with the arrow operator, and then we can access the price here and set it to 5.4. So if we run this program and see what it outputs, like we can see that we have now set the price of this pointer here, and this pointer is like it is like a structure of the product type here. So we can access it down here and just print it out. So now we have like access the price through a pointer to that structure, and then we can like print it out. So we can also have like vectors of structures. So let's say we have like many students, like I'll just go over here again, and we create a new structure here with students, and then a student has a name, it has an ID and an age. So we have these three variables here describing a student, and then we can have multiple students in a class, for example. And if we want to like store multiple students together, like we can store them in a vector, and then we just declare this vector here with the structs, like with these student structs here, and we just call it like students, this vector here of the student structs. And then we can just create the new structs here of the student instances. So we create 4 students in this case here. And then we can set the first student here's name to the coding library, and we set an ID here to the student as well, and an age. And then we just use this pushback function here, so we can push back this structure here to the vector of structures of student structures here, which we call student. And then we can just like, I'll just print it out here as well, so we can see that what we set the name to, an ID and age, so we can see like that it still works with accessing our structure. So if I control B here and run the program, we can see that it prints out the name that we set and the ID and the age. And then we can also like do the same for like the other students here, and in this case here I just do it for the student 4 here. So we set the student 4 here to no name, ID 0 and age 0, and we can then push back that new student to our vector. And then the vector contains now 2 students with like the first element would be student 1 with the coding library here and this ID and age, and then the second element of that vector would contain this 4th student here. So we'll push back it here, and we can see that out if we want to do that as well. But I'll just show you here with the vector where we have this vector now containing 2 students, and we can also we could have like multiple students, like we could have like arbitrary number of students that we just push back to this vector. So we could have like, for example, classes or like a whole university or something like that stored in a vector, or like some other data structure. So we can use this for loop here, which is like, it just runs through all the students. So instead of like I here, I can call it like student for a more intuitive way. So for all the students here, we have like a reference to the students inside of this vector here. So like for every student in this student vector here, we just see out the name of that student. So if I hit Control B here, we can see that it throws an error because I called this I. So we'll now call this student. So the name of the first student here is the coding library, and then the name of the second student in this vector here is no name. And we could do the same here for like ID, and we can also do the same for age if we wanted to get that. And for student, it could also like be grades or something like that, and then we could like store them in a vector, and we can like sort that vector for like grades. So we're like sorting the vector regarding like grades or like age or something like that, if we want like to do that in our application or program. So like we can use structs for some different kind of ways, and it's just like when we have like a lightweight like structure that we want to create with some data types inside of it. And if we want to like create more complex like structures, we should like consider using classes, as we're going to talk about in the next video, where we can also have methods to that class, and we can also like have these private members. So we're just operating with objects in our code instead of like structures that can like be accessed everywhere in our code. So it will probably like make a bit more sense when we are like going over the next couple of videos, where we're going more in depth with object-oriented programming and classes, and how we can use that in C++, and also like why it is so important. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification on the video, and also like this video if you like the content and you want more of it in the future. If you want to like do some practical stuff with the things you learn in this tutorial here, I'm also doing a computer vision tutorial with OpenCV where we're doing some like camera operations and doing some calculations and operations on images. And I'm also doing an algorithm and data structure tutorial. So if you're interested in one of those, I'll link to one of them up here. Or else I'll just see you in the next video, guys. Bye for now.